Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Okay, now we want to find the shortest distance between two parallel planes. So on the left hand side, we have the planes on the same side of the origin. On the right side is the planes are on the opposite side of the origin. As you can see, O is the origin. But in both cases, O, A1 and A2 are collinear, and A2, A1, this vector is parallel to n. So in both cases, the equation of the planes pi1 and pi2 are ax plus by plus cz equals to d1. And the second plane is ax plus by plus cz equals to d2. When the planes are on the same side of the origin, so the left-hand side diagram, D1 and D2 have the same sign. Whereas when the planes are on the opposite side of the origin, so look at the right-hand side diagram, D1 and D2 have the opposite signs. In both cases, the shortest distance between pi1 and pi2 is the same as the perpendicular distance of the point A1 from the plane pi2. So this is given as A1 dot n minus D2 over the modulus of n. Since A1 lies on the plane pi1, it follows that A1 dot n equals to D1, and consequently, the shortest distance between the plane pi1 and pi2 is given by D1 minus D2, the modulus, over the modulus of n. Or equivalently, the modulus of D1 minus D2 over the square root of a squared plus b squared plus c squared, where n equals to a, b, and c. Now, let us look at how to solve the shortest distance between two skew lines. So there are two methods. So the first method, look at this diagram properly. Let the equations of the lines L1 and L2 be R equals to A1 plus lambda B1 and R equals to A2 plus mu B2 respectively. Observe that there are an infinite number of planes which contain the line L1 and an infinite number of planes which contain the line L2 because the planes can rotate 360 degrees along the line. So since the lines L1 and L2 are skew, which means they are not parallel, there's just one plane, pi1, containing the line L1, and one plane, pi2, containing the line L2, which turn out to be parallel to each other. So in this case, the common normal vector n to planes pi1 and pi2 must be perpendicular to B1 and B2. Thus, N is parallel to B1 cross B2. And thus, the equation of planes pi1 and pi2, which contains the line L1 and L2 respectively, can be written as R dot B1 cross B2 equals to A1 dot B1 cross B2 and R dot B1 cross B2 equals to A2 dot B1 cross B2. Let us now consider the diagram above. The shortest distance between the skew lines L1 and L2 is the same as the shortest distance between the plane pi1 and pi2, containing the lines L1 and L2 respectively. This is because it is possible to find the point P on the line L1 and a point Q on the line L2 so that the vector PQ is parallel to B1 cross B2. But the shortest distance between the planes pi1 and pi2 is given by the modulus of A1 dot B1 cross B2 minus A2 dot B1 cross B2 over the modulus of B1 cross B2. And this is quite familiar if you think back the equation that we have learned just now, finding the shortest distance between the two planes, and it is exactly that. So A1 dot B1 cross B2 is D1 and A2 dot B1 cross B2 is D2. And you can see that the normal, they are similar and you can factorize them out. So it can thus be deduced that the shortest distance between the two skew lines L1 and L2 is given by A1 minus A2 dot B1 cross B2 over the modulus of B1 cross B2. This distance is represented by the modulus of QP in the diagram above. An alternative derivation of the formula for the shortest distance between two skew lines L1 and L2 is given below. So L1 is R equals to A1 plus lambda B1, L2 is R equals to A2 plus mu B2. So suppose choosing lambda equals to lambda star and mu equals to mu star gives the points P on L1 and Q on L2 with the position vector P and Q respectively, so that PQ is perpendicular to B1 and B2. Then QP equals to P minus Q, which is equals to A1 minus A2 plus lambda start B1 minus mu start B2, which then equals to gamma times B1 cross B2. Now the shortest distance between the two skew lines L1 and L2 is given by the modulus of QP. But we know that the modulus of QP equals to gamma times the modulus of B1 cross B2. And QP dot B1 cross B2 equals to A1 minus A2 dot B1 cross B2, and equals to gamma times B1 cross B2 dot B1 cross B2, which can then be simplified because when two similar stuff dot together, you get the modulus squared. So gamma times the modulus squared of B1 cross B2. And we also know that the identity of B1 dot B1 cross B2 is equal to B2 dot B1 cross B2. And it is equal to 0 as well. So the modulus of QP can be simplified as A1 minus A2 dot B1 cross B2 over the modulus of B1 cross B2. You don't have to know this method of derivation, it is more complex. What you actually need to memorize is the final formula. So let us look at another method of finding the perpendicular distance between two skew lines. So let us look at the second method. It is kind of the same as the first method, but then the use of formula is a bit different. So in this case, the common normal vector n to the planes pi1 and pi2 must be perpendicular to b1 and b2. Thus, n is parallel to b1 cross b2. So consider this diagram. The shortest distance between the skew line L1 and L2 is the same as the shortest distance between the plane pi1 and pi2, containing the lines L1 and L2 respectively. This is because it is possible to find the point P on line L1 and the point Q on line L2 so that PQ is parallel to B1 cross B2. So we now project the line L1 onto pi2, shown as L'1, and slight PQ along L1 and L1 prime until PQ becomes A1Q prime. Then A2Q prime A1 is a right angle triangle, and the shortest distance between L1 and L2 is given by A1Q prime. Thus, the shortest distance between the skew lines L1 and L2 is given by PQ, which is equals to A1Q prime, and it is equal to the modulus of A2 A1 vector cos theta. So the modulus of A1 A2 dot B1 cross B2, which is the normal cos theta, divided by B1 cross B2, we can then simplify it using the dot product formula or the cos theta formula and obtain A1 minus A2 dot B1 cross B2 over the modulus of B1 cross B2. Again, we reach the final formula that can help us to find the shortest distance between two skew lines. So let us look at an example without using the formula how to find the shortest distance between two skew lines L1 and L2. So this is the longer method because we are not using the formula that we are deriving just now. So we know that PQ is Q minus P. Like we have made an arbitrary point on the line that will be perpendicular to each other. Okay, so Q minus P equals to 2 minus 18, 28, plus mu times 1, 6 minus 4, which is a point on L2, minus P, a point on L1, so minus 6, 3, 9, minus lambda, 8 minus 1 minus 4. And both mu and lambda are a specific number, and we are going to try to find these two numbers. So we have obtained the simplified version, and since we know that PQ is perpendicular to the line L1, so PQ dot the direction vector of L1, which is 8 minus 1 and minus 4, will equals to 0. So we substitute this PQ that we have obtained just now into this equation, and we simplify it, and we will obtain 64 plus 21 minus 76 plus mu times 8 minus 6 plus 16 minus lambda times 64 plus 1 plus 16 equals to 0, which then simplifies to 9 lambda minus 2 mu equals to 1. Also, since the vector PQ is perpendicular to L2, so PQ dot the direction vector of L2 must be 0. So the direction vector of L2 is 1, 6, and minus 4. So we plug in the PQ again into this equation, and we get a simplified version of it, which is 8 minus 126 minus 76 plus mu times 1 plus 36 plus 16 minus lambda times 8 minus 6 plus 16 equals to 0. And the simplified version of this equation is 53 mu minus 18 lambda equals to 194. Now we have obtained two simultaneous equations. So now we will insert the first into the second equation to solve for mu and lambda. So we obtain 53 mu minus 2 times 2 mu plus 1 equals to 194, from which we find that mu equals to 4. And then substituting mu equals to 4 into the first equation, we will obtain lambda equals to 1. Thus, we can then find P and Q. So P equals to minus 639 plus, because we know lambda equals to 1, so 1 times 8 minus 1 minus 4, and the point is 225. Whereas for Q, we know that lambda equals to 4, so substituting back into the L2, and we know that Q is on L2, so 2 minus 18, 28, plus 4 times 1, 6 minus 4, we'll get 6, 6, 12. And that is the position of point Q. So we are not done yet. We want to find the modulus of PQ. That is the perpendicular distance that we are trying to find. So the length of PQ is denoted by the modulus of PQ, which is Q minus P. So 6, 6, 12 minus 225, we got 447. And then the modulus of 447 is the square root of 4 squared plus 4 squared plus 7 squared. And plugging it into calculator, we obtain 9. And that is the shortest distance. Now I'm going to show you the shorter method. So using the formula that we have derived just now, we want to find the shortest distance between these two lines. So A1 is 9 minus 3 minus 5, A2 is 4 minus 3 and 30. And B1 is 1, 2, 3, and B2 is 4, 2, 7. So A1 minus A2 dot B1 cross B2 over the modulus of B1 cross B2, we will get, so A1 minus A2 is 8, 5 minus 6, and B1 cross B2 is 5, 0, and negative 35. So the modulus of 5, 0, and negative 35, we can find it by the square root of 5 squared plus 35 squared, which is 5 root 5. And plugging all the values into the calculator, we will obtain the shortest distance as 10 root 5.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.